have a look at the previous questions raised from 17 to 26. If you insulate, look at the questions asked earlier in the last sessions. Question number 17, review question 17. If we insulate the lateral surface of a rod, then the heat transfer surface areas are side surfaces, they are cross-sectional areas. If we insulate the top and bottom surfaces of a rod, the heat transfer is from the lateral surface, which is pi dl. When there is no variation in thermal conductivity under steady state condition without internal heat generation, the temperature distribution in a plane wall is a straight line. Perhaps this question is on microwave oven. Yes, it is. And the window glass, which consists of two 4 mm thick glass sheets, in between you can experience thermal contact resistance, hence the total resistance becomes much higher than a single 8 mm thick glass sheet. So therefore, these two 4 mm thick glass sheets will conduct less amount of heat. The heat transfer rate will be smaller relative to a single 8 mm thick glass. In a steady heat transfer process, the heat transfer rate to the wall and from the wall are equal. Therefore, at the outer surface, which has a convective transfer coefficient 3 times that of the inner surface, will experience 3 times smaller temperature drop. If convective transfer coefficient is infinity, the temperature difference between surface and surroundings is 0. Heat transfer coefficient is 3 times more, the temperature difference will be 3 times less. If you insert a copper layer in between the original two plates, it adds another resistance and hence the total resistance increases, so this will become a poor conductor of heat. Thermal contact resistance depends on surface roughness, because the interface with rough surface sits one on the other, creates more air gap, and the thermal contact resistance further increases. When two dissimilar metals are joined, the interface acts like very thin layer of insulation, and thermal contact resistance has significance only for high conducting materials. Between two layers of insulation, when you press together, relatively the resistance offered by the air and resistance offered by the insulating material won't be much higher. The difference won't be much higher, hence you can neglect. When you press two materials under high vacuum condition, question number 25, you are removing totally the air, so there won't be any convection and you will have only radiation. Therefore, evacuating the interface eliminates heat transfer by conduction and thus decreases the rate of heat transfer further. And for the last 26th question, the answer is no. In steady operation, the temperature of a solid cylinder or sphere does not change in radial direction, only unless there is heat generation. So now let us take a few more review questions on the topics till date we have covered. Is the thermal conductivity of a medium in general constant or does it vary with temperature? Consider steady one-dimensional heat conduction in a plane wall in which thermal conductivity varies linearly. The error involved in heat transfer calculation by assuming constant thermal conductivity at the average temperature. Instead of considering K1, K2, if you take average thermal conductivity at average temperature, the error involved is none or small or significant. The temperature of a plane wall during steady one-dimensional conduction varies linearly, and in case if you consider thermal conductivity varies with temperature, will it be linear or something else? When thermal conductivity of a medium varies linearly with temperature, is the average thermal conductivity always equivalent to the conductivity value at the average temperature? 31. A pipe is insulated to reduce the heat loss. However, measurements indicate that the rate of heat loss has increased. Are these measurements right or wrong? Question number 31. Question number 32. Consider insulated pipe exposed to the atmosphere. The critical radius of insulation be greater on calm days or on windy days. Why? Consider uniform heating of a plate in an environment at constant temperature. Is it possible for part of the heat generated in the left half of the plate to leave the plane through the right surface? No. Explain. Consider uniform heat generation in a cylinder and a sphere of equal radius made of the same material in the same environment. Which geometry will have a higher temperature at center and why? So some of the questions are on variable thermal conductivity and some of the questions are on heat transfer in conduction with one-dimensional conduction with internal heat generation. And last set of questions are on fins, review questions. How does the overall effectiveness of a finned surface differ from effectiveness of a single fin? Next, hot air is to be cooled as it is forced to flow through the tubes exposed to atmospheric air. Now we want to add fins to enhance the heat transfer. Would you recommend adding fins inside or outside the tubes? Why? When do you recommend attaching fins both inside and outside the tubes? Question number 37. Does the efficiency and effectiveness of a fin increase or decrease as the fin length is increased? Question number 38. Two pin fins are identical except that the diameter of one is twice the diameter of the other. For which fin? A, the fin effectiveness, and B, the fin efficiency is higher. Explain. Now, answers to these questions from 27 to 38 you will find in the subsequent sections. I advise the students to go through further reading of these textbooks by famous authors Sengel, Frank Reith, Incropera and David. And of course, for more clarity, the matter is extracted from my own book, Heat Transfer. You can refer to this also. It's a New Age International edition. And Professor P.K. Sharma is my guide. Thank you for your attention. Thank you, one and all.